So here we go. It's take 3. The first take, well, we'll tell you about it at some other point, but this is our first attempt at making a flipped class sort of video, and the topic today is finding the area between two curves as we go. So the idea is we want to find the area between these two curves. And so formula-wise, what we're going to do is we're just going to integrate, and we're going to integrate from my lower limit, which is the intersection of the two curves, to the upper limit, which is the other intersection of the two curves. And we're going to integrate the difference between the two functions. Visually, what that looks like, if I integrate just the f function, I get the area under the curve, all of this region right in through here. If I integrate the g function, then what I get is this area underneath the lower curve. So if I subtract the lower function from the upper function, basically subtracting the red area away from the blue, what I'm left with is the area then in question, the area that I'm looking for, all of this region between the two curves. So logically, hopefully that makes sense how we go about, or why we go about doing that subtraction. So we'll work some examples. Hopefully it'll make some sense as we actually go on. Next one, we've got the integral where we've got the f of x is x squared plus 2, and g of x is negative x. There's the graphic of x squared plus 2, a bit of a parabola, and negative x is this function right here. So my window's a little odd. We're going to integrate between 0 and 2. We're going to try to find essentially the area in this region right here. It's highlighted for extra special visual effect, and that's what we're looking for, is that area that's yellow but inside the two black lines as we go. So if we're going to integrate this, we're just going to integrate the upper function, the f of x, x squared plus 2, subtract the lower function, dx, and we're going to integrate from the lower limit 0 to the upper limit 2. As we work our way through that, we want to simplify this a little before we integrate. This turns into x squared plus x, because of the double negative right here, plus 2 dx. And integrate again from 0 to 2. This is an integral we can easily do by hand. It's just a polynomial. Power rule will work really nicely. So we'll integrate x squared. We'll get x cubed over 3, x squared over 2, plus 2x. So that follows for you. We're going to now evaluate it at 2 and at 0. So we plug 2 in, 2 cubed over 3, plus 2 squared over 2, plus 2 times 2. If we check the lower limit, 0 plus 0 plus 0, so we don't need to worry much about that. It's 0 on the back end. 2 cubed is 8, so we have 8 thirds. 2 squared is 4. 4 divided by 2 is 2. 2 times 2 is 4. So 2 plus 4 is 6. We've got essentially 6 plus 8 thirds. 6 is the same as 18 thirds. So we've got 18 thirds plus 8 thirds, which is 26 thirds. So that, my friends, is the area between those two curves. Is that right? So slow it down, take a look, make sure that all makes sense with you before you move forward, because the next example a little more difficult. So as we always go, we get a little more complex as we work our way through. So this time I haven't given you the graph. We're going to try to sketch the graph, and we'll need to find the intersections so that we can integrate. Probably would sketch first. I don't know why I wrote intersections first, but a sketch is just a sketch. This function, g of x, is to y equals x, right there. Oops, let's make some x and y axes here. As we go, this is y equals x, the g of x function. 2 minus x squared we know is a parabola. It's an upside down parabola because of the negative sign. Intersection is about 2, so it looks something like that. So we've got to find this point of intersection and that point of intersection. How do we find a point of intersection? We just look for the place where the two functions are equal to each other. So we say 2 minus x squared equals x. We could jump to tables, we could jump to the calculator, we could, find the intersection, graph it, but we can do this one pretty easily by hand. It's just a quadratic. So we'll just say that 0 is equal to x squared plus x minus 2. Check my algebra there. I think it's okay. Quadratic formula work here, but relatively simple one. We can factor it. It's going to be x and x. Quick factors of 2, 1 and 2. So I'm going to put a 1 there and a 2 there. Since this last sign is negative, we know we're going to have a positive and a negative. Bigger number gets the first sign. First sign is plus. Other one gets the opposite sign. So we end up with x equals 1 and x equals negative 2. So we're going to integrate this function from negative 2 to 1. And we're going to integrate the f of x, the upper function, minus the g of x. So 2 minus x squared, subtract x, dx. So let's have at it. We can integrate this again using the power rule. 2x minus x cubed over 3 minus x squared over 2. And we're going to find out what the values are at 1 and negative 2. We need to go down a little bit. Lost the picture a little bit. That's okay. All right, so plug 1 in. 2 times 1 minus 1 cubed over 3 minus 1 squared over 2. Subtract. I'm going to put it in brackets so that we can make sure we don't lose any signs. 2 times negative 2 minus negative 2 cubed over 3 minus negative 2 squared over 2. Okay, close the bracket for Annie. We're good. 2 times 1, so we end up with 2 minus the third minus a half. Here we've got 2 times negative 2, which is negative 4. Subtract the negative 4, we end up with plus 4. Here we end up with negative 8 over 3. This negative sign makes it positive. This negative sign makes it negative again. So we end up with negative 8 thirds, minus 8 thirds if you like. Negative 2 squared is positive 4. 4 over 2 is 2. So we have a negative 2 inside. And when we do the minus the negative, we end up with plus 2. So let's gather up the pieces, see what we end up with. 2 plus 4 is 6. 6 plus 4, I think, is 8. Let's see. Negative 1 third minus 8 thirds, that's negative 9 thirds minus a half. 9 thirds is 3. So we really have 8 minus 3 minus a half. 8 minus 3 is 5. 5 minus a half is 4 and a half. Let's call it 9 halves. Be done with it. So 9 halves, that's how much area is living right here. So this is just preliminarily, this is the first step in our applications of integration. What we're going to end up doing eventually, later this week, is start to spin this region around the x-axis, around the y-axis, around y equals x, and we'll get some three-dimensional shapes, and we'll start figuring out the volume of those three-dimensional shapes. But that's not what we're doing today. Today we're still just focusing on finding the area with some integration, but shape of things to come. Next problem, by the way, go back, slow that down if you need to. Next problem turns out to be this one right here, which is 3x cubed minus x squared minus 10x, and the other part is negative x squared plus 2x. There's my graphs from the calculator, bar. But you notice on this integral, over here, the cubic function's the upper function, and through here, the quadratic's the upper function. So we're going to have to deal with two different integrals because we're doing the upper function, subtract the lower function. Okay, so we'll figure out how to work that. We need to find out these three intersection points. We'll do it the same way. We know we can use the calculator, and we will actually use the calculator before we're done here. But for right now, we're just going to work it out, and it'll be pretty quick work to find the intersections. Set the two equations equal to each other. Delightfully enough, the negative x squareds, go away, so that's good news. This leaves me with, really quickly, 3x cubed minus 12x equals 0. That's an x. Minus 12x equals 0. Okay? So These have a greatest common factor of 3x. Leaves me inside with x squared minus 4. I can factor x squared minus 4 into x plus 2 times x minus 2 with 3x in the middle, okay, or outside or wherever it is. Leaves me with 3 roots. X equals 0, x equals negative 2, x equals positive 2, which, if we go back to the picture, turn out to be right here, negative 2, 0, 2. So from negative 2 to 0, we're going to integrate with this function on top. From 0 to 2, we're going to integrate with that function on top. So we can quick set up these integrals. I'm probably just going to not write all that work out. I'm going to go from negative 2 to 0. We're going to do the f of x minus the g of x. And add to that the integral from 2 to 0 of the g of x minus the f of x dx. So we know the calculator will do this work for us. We can make it happen, make it so, if you will. We can set up the calculator to do all of this work. Just find those two regions. Oops, I don't want the fancy pens. I was just looking for a little green highlighter. So the green region is what we're going to get from this integral. The yellow region is what we're going to get from this integral. So next screen here, I've got the calculator set up to do this. I've just got actually a bunch of calculator screens, but you can follow along. So we put the two equations in, y1 and y2. As we work our way through this, the next thing I did was I did y1 minus y2 in one of them and y2 minus y1 in the other one. So, see if I remember, this is the green region, and this is the yellow region. Did I do that right? Let's just check. Yeah, I did. Okay, cool. So when I go further, I can shut off these other two functions. I can just have one function showing up at a time, and I just highlight the part that's there, and I hit enter, and shuts them off, turns them on. So I just graph y1 minus y2, the green region. Gets me a cubic. I use my integral function on the calculator, and I end up with 12 as my region right there. Okay? Did the same thing, went back, shut off y1 minus y2, and just did y2 minus y1 to get that second half, the yellow piece of the curve. Graphed that, got this curve. Used the integral function, got this curve. As it turns out, the integral in this case is also 12. So the first region, the green region, its area is 12. The yellow region has an area of 12. 12 plus 12 is 24. That tells me the area of this whole region right here, the area between these two curves, right like so. Okay, you know how to use your calculator to follow along with that. Slow down, you can go through and do the steps if you'd like to. If you have questions, bring them with you tomorrow to class, and we'll try to answer those, and we'll work through some problems, some practice problems, so that we can do this, so then we can move on to the real fun stuff of spinning things and making three-dimensional objects out of crazy math curves. Thanks for viewing. View it again if you need to. Get some questions for me. Thanks. See you later.